I'd like to take 15 minutes to introduce you to Ops Manager for MongoDB. Ops Manager is the management application for MongoDB, available as part of MongoDB Enterprise Advanced and created by the engineers who write the database itself. I'm going to take you through several scenarios and explain to you how your life can be made easier by using Ops Manager. First thing I'm going to do is log in. MongoDB Ops Manager allows you to have multiple administrators in multiple groups. Groups can be independent from each other so that they can administer and manage entirely different projects, or groups can be, an admin can be in multiple groups, or an admin can be system high and see all groups. So it allows you to work in a small organization or a large one. Here we're looking at my group called Production Devices. And I have two MongoDB setups here. I have a two-node cluster called app data with the data from my application, and I have a three-node replica set called user details. So the bottom set is user details with the primary and two secondaries, and the top set is app data, each having two shards, each having a primary and two secondaries. The first thing I need to deal with today is this morning we had a production outage. We received no notifications from Ops Manager. There were no errors, but our system was actually unavailable for 8 minutes. So I want to go into Ops Manager and look at what happened during that time period and understand why the system was unavailable and why I've had, there are no warnings or notifications here that there has been a problem. So I'm going to go in and view the metrics for the main app data cluster. And here I'm looking at data of the last minute, a 1 minute granularity for the last 24 hours on the primary servers. And I can see from this that this morning there was a sharp dip in the data. So I'm going to zoom in that dip and understand what happened. And I can definitely see that I went rapidly from having 600 or 700 queries per second to having 0 operations per second. If I look at update operations, I see a similar pattern. I had approximately 120 updates per second at that time, and they dropped to 0. So that certainly shows that something was wrong, whether it was at the server end or the client end, or the application server end rather, I don't know at this point. But let me drill in further. So rather than looking at the whole cluster and my two shards, I'm going to drill into a single shard and look at the primary and two secondaries for that. And I can see the same behavior here. And the dip across all of the operations, and looking down, the secondaries wouldn't have been doing those operations. There are no major page faults. There do seem to have been some jumps in memory. Let me go back and look at the full cluster again. We'll zoom in to that time period and look at what was happening on the secondaries. So I already have some information that the secondaries also took a dip, but you can see that the secondary dip happened after the primaries. So whatever the operation was, it impacted the primaries first, and then once it was no longer impacting the primary, it impacted the secondaries. That would suggest that it is something on the database side. So let me drill in and look at a single primary on one of my shards and see if there are any clues there as to what happened. So I see a number of page faults here, but the page faults actually are only 0.3 page faults per second. So one page fault every 3 seconds, that's not causing it. I'm not seeing any other notable things in there. Let me just choose the right time period. The queues increased, so that suggests that the database wasn't doing things. The network dropped. The cache activity dropped. So all of this is telling me what I already know, that for some reason the database stopped accepting things. So let me go in one stage further and have a look at what was happening with the database itself. So this is looking at POCDB, which is an individual database on that instance. And now I see something significant at that time. My index size jumped by about 500 megabytes, and I have a new index. So now I have a strong suspicion what happened. I believe that somebody chose to create a new index at that time and created it as a foreground index. Let me just verify that by going into the logs. So I can access all of the logs also from Ops Manager, and I'm looking for the logs at 8:30 this morning. It's currently 11 o'clock, so I'll need to go back several pages. .21, several more pages. 10:06. These are 9:13. This is just basic level of logging in here. Obviously we have users logging in and logging off, and we're recording that information. And 8:50, so we're nearly there. 8:40. And here we are. So now if we look, 8:31 in the morning, index build, 98%. So the reason for my downtime is somebody chose to build an index without building it in the background. Now, that's indicative of a developer either manually building an index and choosing to create an index without thinking to do it in the background, or having a piece of code that uses the deprecated ensure index function, which says if an index does not exist, then create it, again without the background option. So the way you create an index on a development cluster is very different to the way you create an index on a production cluster. On a production cluster you should create it in the background so that it doesn't impact things that are running. It will take longer to create, but it will run while the system is running. Or you can do a rolling upgrade where you would take a secondary server down, create an index on the secondary server, bring the server back up again. You can use Ops Manager to do that for you, so you can do a shutdown of the server from Ops Manager. And what you would do is you create the index on the secondary, bring it up, then once it was in sync, take another secondary down, repeat, and then you would do it with the primary. So by taking the primary down, one of the secondaries would become the new primary. But in this case, what's happened, I believe, is that a developer's pushed out a piece of code that's created an index, and that's caused us downtime. So we need to, firstly, we need to identify issues like this in future, and secondly, we need to prevent them. Now, one thing we've done in setting up MongoDB here is we've not used any security. Our MongoDB is on our own servers, it's behind a firewall, it's not exposed in any way to the internet. It's only exposed to a very limited number of our application servers. And so we didn't feel there was a need to implement authentication. But that was probably a mistake, because if we'd used authentication, which is easy enough to turn on in here, I can simply click up here and go in and say, I would like now to be using usernames and passwords and or client certificates to log on. And in fact, it's not letting me have that one because I only have Enterprise, and I don't have Enterprise installed across all of my servers. I can turn on SSL if I want, and I can basically set this up. I'm not going to turn this on now because our current clients aren't set up to log on with a certificate or to use a username, so obviously turning that on would create the downtime we're trying to avoid. But once I've done that, I would then go in and create a role for my application user on the appropriate database, which is called POCDB, and I would call that app user, and then I can set the privileges they require, which is basically find, insert, remove, and update. But what they don't need to have is things like create index. So we would change it so that rather than running with all applications having the same security credentials and an index can be created by an application, we would change it such that creation of an index happened as an administrative task and was done through Ops Manager or from a command line. So that's just a good example of why, even if you have an outside security inside MongoDB itself can protect you from simple mistakes that you might make. Another thing I should probably do with this, if I go back to my deployment page, is when the system drops to no activity, I probably want to know about that. So I have some alerts set up on this system in the Activities tab, but I don't have one for that. But I could go into Alert Settings, add a new alert, and say if a host of any type, or actually if a host of type primary, op counter for queries is below 5 per second, so basically for any reason we're not getting the kind of throughput we expect, then I would like you to send emails, and there are other things it can do. Send email, connect to my SNMP server, connect to a webhook, things like that. Let's not set that one up just now. In fact, yeah, why not set that up? Okay, so now not only will I be notified immediately if we have this kind of downtime in future, but I'm going to talk to the developers about going in and adding security to the system. Now, I'd quite like to use Kerberos security for this, and in order to do that, I'm going to have to upgrade this cluster. So we have MongoDB Enterprise, that's why we have Ops Manager, and you see that my main cluster is running 306 Enterprise. However, my user details cluster is running 304 Community Edition. So it should be on 306 anyway, it's time to upgrade that. Now, the procedure for doing an upgrade on a live system normally is similar to what I described with rolling index builds. So I would first take down a secondary, then I would upgrade it by replacing the binaries, then I would bring the secondary back up, allow it to come into sync, and then I would repeat that for the second secondary, and then I would ask the primary to stand down, one of the secondaries would take over, and I would upgrade that. So it's called a rolling upgrade. It's not hugely complicated to do as long as you're very careful on a 3-node replica. Once you get onto a sharded cluster where you might have 6 or 12 or 100 servers, you really want to be writing scripts to do it. Except you don't want to be writing scripts because Ops Manager will do it for you. And let me show you what's involved in upgrading that cluster. Click here, tell it I want that cluster to be 306 Enterprise, and I can also at this point change any other options on here. So you see I'm running these with the Wired Tiger option engine, and I can add other options in here. So I could say that now I want to be using, I want to set the slow MS value, for example, to record any operations that take more than 50 milliseconds. And then I can click Apply. It will ask me to review the changes I want to make. So it's saying, right, you want to set slow MS to 50 milliseconds on this replica set and upgrade the version from 304 to 306 Enterprise. So I'll confirm that, apply that change. And that will now apply that change in the same rolling fashion with no downtime, no interruption to my users. It will apply that change across all of those servers. So it's just confirming there. It's not only confirming that it's updating the cluster I've asked it to change, but it's also confirming for me that the rest of my servers are in an appropriate goal state, and that's that complete. So now this is running 306 Enterprise. Now the final thing we want to do, so we've done some diagnostic work, we've looked at the monitoring, set alerts, user management, we've upgraded a cluster. Final thing we want to do is backup. So my user details cluster, we currently back up by running MongoDump, and we run it every night at midnight, and it creates as a dump of the data in there. The problem is that we only have a backup as of midnight, and a 24-hour recovery point objective is unacceptable. Again, Ops Manager makes this very easy for us. We can go into backup, we can say user details, I would like you to start backing up. I'd like you to do an initial sync from any secondary. So basically what it's going to do is it's going to take a copy of the data into the backup store from a secondary so it doesn't impact a primary. And then thereafter, what it's going to do is it's going to take incremental backups every minute. So you actually have a backup made every minute. You have a 1-minute recovery point objective for the last 48 hours. And then in order to cut down on size, it coalesces those into snapshots after that. So you would have a backup for every minute for the last 48 hours. Thereafter, you'd have a backup, for example, for 1 hour for the next week, and then 1 week for the next month, and then 1 month going back as long as you like to have. But you can set that retention schedule, and you can do restores from it. Either you can restore via SSH or via HTTP. You can restore data back onto a test cluster. It doesn't have to restore back to the cluster that it originally came from. So this is MongoDB Ops Manager. It provides you with monitoring, it provides you with historical recording, which means when you need to go back and understand the trends in your system, what's happened over time or what happened yesterday, you can do it. It gives you access to your log files without logging onto the servers. It gives you access to database profiling without logging onto the servers. It allows you to deploy, upgrade and modify a cluster, including extending it. It allows you to manage your users and roles. It allows you to back the system up. Everything you need to make your life much easier when you're managing MongoDB. If you want more information, please contact MongoDB at sales@mongodb.com.